The Piping System Builder is a standalone piping design tool in the GLD family. The Piping System Builder is fully compatible with all geothermal loopfield design software tools. The builder takes your loopfield design, for example, the number of required boreholes or the number of rows of pipe in a trench or pit, and automatically turns it into a specific, optimized piping design and piping bill of materials. An optimized design has the following characteristics: efficient flushing and purging prior to system startup, optimal Reynolds numbers for effective heat transfer, minimal circulation pump requirements. The Piping System Builder does all of this automatically, and it does it fast. In fact, it only takes about a minute to design, build, optimize, and print out a piping bill of materials for a commercial geothermal system. Let's see how it works. Let's say we are working on a 24 borehole system, and each borehole is 350 feet deep, which means that each circuit is 700 feet long. Notice that the circuit pipe diameter warning light has come on. The program is telling me I should increase my circuit pipe diameter. When I change it to 1 1/4 inch, it says everything looks good. On the Modules tab, I specify the number of boreholes on each supply return runout pair or module. I will put 8 boreholes on my first runout pair. I will put 20-foot spacing between boreholes, and I will leave it as a reverse return headering system. I will specify the supply return runout lengths next. I can input, say, 100 feet on the supply runout and 120 feet on the return, and you can see that the circuits per module warning and the runout diameter warning are both on. If I bump my pipe size up to 3 inches, those warnings should go away. Next, I'll make 2 copies of this first module and quickly build my 24 borehole system. I'll go back to Module 2 and change the supply return runout length on it to 150 and 170. Then I'll change the runout lengths for Module 3 to 200 and 220. I'll take a quick look at the system via the summary panel to make sure everything looks good. On the Manifolds tab, I can specify the separation distance between the supply runouts on the manifold, as well as the manifold pipe size and the lengths of the supply return runouts to and from the manifold. For this design, I'll leave the separation distance at 1 foot between supply runouts and use 4-inch STR 13.5. For my runouts, I'll put 50 feet on the supply side and 60 feet on the return runout. If I am concerned that my system will be unbalanced, I can add balancing valves here. For larger systems that have a variety of runout lengths, systems oftentimes benefit from balancing valves. When you add them in here, all of the calculations are done automatically, which saves a lot of time, and the design ensures that you have equal flow through each supply return runout pair. The Pre-Manifold tab is for very large commercial systems. We don't need it for this design. On the Fluids tab, I specify my fluid flow rate. This is the flow rate that goes through the system to ensure that the Reynolds numbers in the heat exchanger circuits are in the proper range. I also specify the fluid type. I'll input 140 gallons per minute and select propylene glycol with freeze protection down to 15 degrees. I'll be aiming for a minimum operating temperature of 25 degrees for the selected fluid. Now let's watch the magic. I'm going to send this design to the calculation engine and see the results. The Overview tab has 3 sections. The Summary section at the top summarizes the design. It shows me the total pipe length for the system and primary heat exchanger circuits, the number of modules and manifolds, the number of circuits, balancing valves, which we are not using for this design, the fluid type, and the system fluid volume. You can also see a pumping power score and a 1 to 5 star rating. This is a pretty well-designed system, and so we got a low pumping score, which is good, and 5 stars. Honestly, with this tool and the type of feedback that it provides, it's pretty hard to design a bad system, It can be done, but it requires some intentional effort. The operational performance section provides analytical results related to the flow rate, the pressure drop, and the Reynolds number values in range. You can see here that the lower value is in red, indicating that I might not get the turbulent flow that I want in one or more of my boreholes. We'll come back to that in a moment. The power performance section shows me the peak load for the design, which you can enter for each design you are working on, and the calculated total circulation pump power. In general, people tend to oversize circulation pumps, which leads to a lot of wasted energy, as well as what we call phantom loads. This system requires only a 0.58 horsepower pump. The purging performance section shows me exactly what size of a purge pump I will need to purge this system prior to startup. In this example, we need 73 gallons per minute at 20 feet of head. The pump will require about 0.6 horsepower. Now let's go back to the operational performance and see if we can fix that red Reynolds number. In this example, I'm going to bump up my system flow rate a bit. I can do that in a couple of different ways. In this example, I will just rebuild the entire project with a higher flow rate. So I'll delete this design, change the flow rate, and then send it back over. And there you have it, an optimized piping design. Now let's take a look at the piping bill of materials. This list shows me the types and lengths of pipe I will need to build this system. It normally takes hours to determine all of these pipe sizes, types, and lengths when a designer is preparing a material estimate. Now it's instantaneous. Pretty nice, huh? The Piping System Builder makes it really fast and easy to design and optimize piping systems. If you have any questions, please contact us.